Welcome to video number 4 of Tasks in Scala. Today we're going to be talking about lists. With every video I want to say something so much fun, but I think almost everything is fun, so yeah. The task of today is going to be, for the price list of 3 auto shops, give an overview of the number of prices in total, the highest price and the 2 lowest prices. At the end, I will give you some more details. As always, I definitely suggest you ride along. Now, the first topic we're going to tackle before we get into lists is immutability. This is a very important topic in Scala, which also really distinguishes it from other languages. And I will just show you what we mean with immutability. So we have been talking about values, like for example, a number of the type int, and we assign it the value 2. Now, if you print this, of course, we know that it's going to be printing 2. What we cannot do is change our mind and say, you know what, I'm going to assign it 3. I think that's a better number, so I'm just going to do that. Because it says reassignment to val, which stands for value. This is not possible because of immutability. This becomes immutable. We've decided it is 2, and that is what it's going to be. Now, there is actually a way to work around this if you would want, which is a var, which is a variable, because this is mutable. So exactly that thing we were talking about, like another number, and I say it's 18, then we print it, and then afterwards we say, you know what, I just really like 42, so I'm just gonna reassign this. Let's print it, and this will actually work. It doesn't give the same problem as it had here. That is because a var is mutable and a value is immutable. In Scala, we always prefer immutability. Let's write this correctly, immutability. Unless you have a really good reason not to do so. So I'm being dramatic, but this is practically the way. Why is immutability so amazing? Because you don't get confused. And there are more reasons, but this is the main reason I will talk about right now. If I declare a number here and I give it the value 2, then if at any other point a number pops up, then I know it is going to have this initial value. Whereas here we start with 18, but I changed my mind to 42, and who knows, maybe 100 lines of code later I decide that I want it to be 37. So immutability has some really nice properties, and we're going to be seeing that immutability in lists as well, and we're going to talk about them right now. So let's create a list of integers that will have the type list, and then you have these brackets of int. So you can say this is going to be a list of this type. And we create a list very easily. We just say list with open and close parentheses. And for example, we're going to say 1, 2, 3, 4. Let's print this. It's called a list of integers. And it prints the list of 1, 2, 3, 4. So this is a list. Now, lists are immutable. So for example, it is not going to be possible to say, well, of this list of integers, let's just delete the last one or something like this. Like, I'm just inventing this, but something like this does not exist. It's the same as with the val over here. Once I've assigned the list of 1, 2, 3, 4 to a list of integers, this is what it's gonna be. Let's check out another list, a list of strings, a list of strings. So we write that again with list and with the string between the brackets. We can create a list of fruits, for example, apple, cranberry, banana, and dragon fruit. Just for the sake of, I always print everything to show you. Let's print this. Oh, I did something wrong. Unclosed string interpolation. That's correct because over here I opened the string but I did not close it. Sorry. So you can actually see that the errors really help you if you do something wrong, right? That's really nice. Okay, so you've seen two different lists right now. Now a list in Scala consists of a head, that is the first element, and then a tail. And I write it with this operator, which consists of two double colons, because that is the way you can actually write it in Scala too. So for example, our list over here, we have the head, that is 1, because it's the first element. And then the tail consists of the rest in a list. So you would write it like this. And this operator practically glues them together. So similarly for the strings list, well, I'm gonna copy this part to make it a little bit faster. So once again, the head is the first element and the tail is the list that comes afterwards. And you can actually also access a few handy methods on the list type itself. So for example, on the list of integers, we can just ask for the head and we can ask for the tail. And you see that the head is indeed the number 1 and the tail is a list of the 2, 3, and 5. Let's do the same thing for a list of strings. We get the head and we get the tail, just to show you. Great, so you see that it all works out. Now, let's just go a few steps deeper. So we start with a list of 1, 2, 3, 4. Now you know that this is the same as the element 1 as the head with the tail 2, 3, 4. But we can just keep decomposing this because this list is equal to the head 2 and then the list of 3 and 4. We go one step further, we get the head is 3 and the list is just a list of 4. And then the final step is 1, 2, 3, 4, and finally an empty list. And an empty list is also called nil. This is exactly the same. So we can just check this in Scala as well. We create another list of ints. And I'm just gonna paste this so you can see that this will actually work. Well, let's hope it does, right? Another list of ints. And print this out. And you see that this will actually be interpreted as the list of 1, 2, 3, 4. And as I stated, the empty list is equal to nil. Perfect. Okay, now we're gonna do some fun things with multiple lists. So let's try to glue two lists together. Well, nobody calls it gluing. Usually this would be called merging or concatenate. Let's say we have another list of higher numbers, which is 5, 6, 7. And then we're going to make one big list of the first list that we had, glued together, and we do it with this operator, so it's a little bit different. And we glue it with the higher numbers. Let's print the glued list. And you see that we get one big list from 1 through 7. So this operator is to glue one element to a list, because this will compile to a list. You can see it much better here, right? So you have a list, and then you glue one element to it. But in this case, we have two lists, and we glue the two lists together. Now you can also use an alternative method, differently glued list. Wow, this is an amazing word, I must say. Let's switch them around. We take the higher numbers first, and then we glue them with the double plus. This is just going to do exactly the same. Now I have to write this whole thing. Differently glued list. And indeed it gives us the list, which starts with the elements from the higher numbers list and then the initial list that we already have. Now, here we already saw that you have a few functions available to you on the list type, which is the head and the tail. Now we're going to check out some more functions. Oh, if it... Yes. We're going to look at some more list functionalities. So we already saw the head and tail, and I'm just going to print them directly so you can just check them out. For example, the size, that is just going to count how many elements are in there. Higher numbers. And I have to write the name correctly. So in the higher numbers list, we only have 3 elements. That's correct. Another function is called reverse. And you're going to be so surprised what it does. It reverses the list. Now, I told you before that lists are immutable. Did I actually write it wrong again? Wow, this is amazing. I told you before that lists are immutable. So this will not change the higher numbers list. This creates a new list. And this is the new list. Very important to realize. Now, for example, if I wanted to get the last element of a list, then now I could do reverse and then the head, right? Because if my list was 5, 6, 7, then the reversed list starts with 7, and then the head would be 7. So then I get the last element of my higher numbers list. But this is equal to higher numbers, I wrote it correctly, and then last. You just grab the last element. Let's see if it prints. Or did I write something wrong? Oh my goodness, I wrote it wrong again. Two. Yeah, 2 times 7. I think my internet might be a little bit slow. Now, one small comment here, which is not the most important thing right now, but just something to keep in mind maybe, is that performance-wise, last, the operation last, will be much slower than head for the list type. Why? Now we can go back to this little sequence. A list consists of the first element and then the tail. So if you want to get the head, then Scala can just grab this element right away and it's done. But if you want to go to the last, what Scala is going to do is going to be saying, well, is it the head? No. So I have to go into the tail. Is it this one? No, because I still have a tail to check out. Is it this one? No, because I still have a tail to check out. Is it this one? Yes, because now I have an empty list as my tail. So for last, it will have to go through the whole list. And for head, it can just access it immediately. For the things that we do, that is not very important, but it's just, in the future, if you are programming, it's going to be about much more than just understanding how to make stuff work. And then things like this. Whoa. I don't know what that was. Things like this will start to matter. Okay, I have another fun function. We're going to try it on a list of strings. We're going to try to sort it. And we do that with the sorted function. As you maybe remember, it was a list of fruits, and it was apple, cranberry, banana, dragon fruit. And if you would sort that alphabetically, you would get apple, banana, cranberry, dragon fruit, just as it's doing. So what the sorted function does, it just takes the most logical sorting function. So for strings, that would be alphabetically. But for numbers, it would just be from low to high. Let's make a scrambled numbers list, because now I've just been making very neat lists, and there's no need to sort them. So we just make a scrambled, I forgot the B. My typing is having a hard time today. Scrambled numbers dot sorted. And it's just going to sort it from low to high. Very nice. I just want to make a little bit more of a comment about immutability. Immutability, the list that you start with, so that you take as an input, does not change. You are creating a new list and you're using the other list as an input. So as an example, we can just take a list that is called A. I'm making it myself really easy right now. And then I'm creating B, which is, oh no, I hear sirens. I wonder if it has to do with the little explosion that we just heard. If I say A dot reverse, then that means that 1, A has not changed, and 2, B has the value list 3, 2, 1. Why is this useful? Why? There are no side effects. I'm just going to write it out. I think it would be handy maybe for you to write it out to have as a little bit of documentation for yourself, useful. Or you could also say, why is that important? Why did Scala opt for this? Well, of course, I'm not the creator of Scala, but it is so incredibly useful to not have side effects. If I create a list 1, 2, 3, and at some other point I do a reverse, I do a sorted, whatever I want to do on the list, that does not change what the value of A is. I can reason very easily about what my program is actually doing, what is happening in the code. There are no unexpected surprises here or there, because this simply doesn't change. And I do have the possibility to use it as an input to make another thing. So even if I would remove the assignment part and I would only say A dot reverse, that is not going to change A. The only thing that happens here is that you are creating a new list, and it's in vain because you're not assigning it to a new value as we were doing with value B. So just a reminder that lists are immutable too. Okay, now I already told you that nil is the empty list. Let's create a short list with nil. We're just going to say 1, 2, and then nil. So this will be a typical way to write this. I mean, instead of the list with the, like this. Instead of writing list and then open and close parentheses with nothing in between them, that's not really the typical Scala way. You would definitely write nil. And now we can actually do a check whether this list is empty. So we do it like this. We write another short list, and then we say, is empty, with a question mark in our head, but we don't write it down. And it says false. Well, of course, because we have 2 elements in this list. We can also say, wait, the nil, is this one empty? What do you think the answer is? It is true. The nil is empty. This is a tiny check, you know, it will come in handy sometimes. Okay. We're gonna look at a sort of an example task that will help you perform the task that we talked about in the beginning, for which I'm gonna give you some more details. It's going to be, we create a report about my grades. So let's say that I have a list of my grades, and it's gonna be from 0 to 100. And it's 90, 87, I think I did really good. Then I did a little bit less, 89, and finally 99, almost perfect. Now, let's make a fun report about this list of grades. We're gonna make a function for this. Let's say definition, report on grades, which is gonna have the input of a list of integers, which is going to be called grades, and the output is going to be the string, which will contain the report. So for example, the first thing that I can do is how many grades are in the report. I'm going to use an interpolated string, number of grades. As you know, you can use the $sign to insert some data. But if you want to do anything more than just grades, you will have to use the curly brackets. So we're going to say grades.size, because this will count how many grades we have in the report. And then to make it look really nice, I'm going to put in a new line, and I'm also going to go to a new line here just for readability. But you know very well that that does not cause the new line. So what else do we want to know about the grades? I want to display them from low to high. Grades from low to high. Then once again, we can use the $sign with the curly brackets, and we're going to say, well, let's just sort this thing. And another new line. And then finally, I just want to grab the lowest and the highest grade. First the lowest. To end with good news, I'm just going to say the lowest grade first. So for this, we can use, for example, there are multiple ways, right, to do this. But for example, we could just sort it first and then take the head. But as you've already seen, no, am I confused? You have to sort it. Yes, you have to sort it first and then take the head. No, you cannot take the tail for this because it will give you the wrong answer. That is what we're going to do in the next one. We're going to take the last element of that. Sorry, I got confused. Okay, highest grade. That is going to be sorted, and then we take the last element. Although in general for programming and for lists, there are so many ways in which you can solve the same thing. As we saw before, sometimes performance-wise something can be faster than the other thing. Sometimes The code might look cleaner if you do it in one way or the other. But in this case, I was wrong. This was just the way to do it. Okay, now let's just test this out. We're going to create the first report. We're going to call the report on grades function, and we're going to give it as an input the grades that I wrote down. That is going to give us a string, and we're just going to print the string. Yay! Okay, number of grades, 6. Yep, that's correct. Grades from low to high, 45, 67, 87. Yep, that goes from low to high. And then the lowest grade is 45 and the highest grade is 99. Awesome. Older grades, another list. And oh, I started out really bad. Then I went up a little, then not so good. This report, you know, it's not my finest work. Let's just see what it will print out to be. A report on grades. We plug in the older grades here. And let's print the second report. Number of grades, 8. Oh yeah, I put in more grades. Then we have the grades from low to high, the lowest grade and the highest grade. Perfect. Now what we could also do is, for example, we create another report and report on grades. And we're just gonna say, well, I got a few new grades. I'm just gonna write them down here. 45, 34, and then the rest of the grades that I already had. So this will just create this list on the fly, and we just plug it in right away into the report on grades function. Let's print that. I think my internet is a little bit slow because it's trying to connect to SBT for Scala. You can do it. It could do it. Great. Now, did it actually add the new grades? Yes, it did, because I put in a 34, and in the original grades list, there was no 34. So it just created a new list and used that for the whole function. And here the highest grade is 100. Awesome. Now we're going to make another type of report that is going to compare grades. I'm typing, but you cannot see. Now you can see it. So we can compare the older grades to the newer grades. And once again, it's going to give a string. Now, for example, what can we want to know from this? We can say we want to know what was the lowest of the old grades. Lowest old grade. That was older grades. We sort that and then we get the head. And the lowest of the newer grades. Newer grades dot sorted dot head. I'm gonna put in a new line, but I'm also gonna go to new line here because otherwise it's gonna be hard to read. And now let's say that we want to know how many grades do we have in total for the two lists together. Now there are actually two ways that you could do this. Let's just start with the first one. Amount of grades. Oh no, made a beautiful letter from that. Amount of grades combined. We could go crazy and do, for example, older grades size plus newer grade size, because it's just gonna determine what is between these curly brackets and plug that in. Okay, let's just try this. I haven't tried this before, I just came up with this, so it's gonna be interesting to see. Compare grades, then I already made two lists for that, the old grades and grades. We're just gonna print it directly. Now, see that I did not actually make a separate val as I've been doing before, just to save myself some work, save some time. And it worked. So we have the lowest old grade, the lowest of the newer grades, and then the amount of grades combined. Let's see if that's correct. 11, 12, 13, 15, 15. Oh no, did I count it wrong? Oh yes, I counted wrong. This is 8 plus 6, that is 14. Okay, thank you. The computer is much better than me. That's why we use a computer. So this whole thing computed the correct thing. Now the option I actually was planning to go with is just to create a val within the function, which we're gonna call combined grades. And we just quickly create a new list of the older grades glued together with the newer grades. And then over here, we can just use the combined grades list, and we take the size of that. So this should also give us 14. Let's check if that's correct. And it does. Now actually applies what I said before. You can decide what it is you want to do. Now, I would personally go for this option because I don't like to have a lot of logic within these two curly brackets. But as you saw, it actually does work. So that is just up to you. So we talked about immutability and that it's a very important topic within Scala. We always prefer immutability unless you have a really good reason not to do so. Then we started checking out lists. We can create lists which are collections of different elements. We checked out how a list is actually built up within Scala and how we can use the head and tail and some other fun functions on the list. So these are all functions that you get for free when you use the list type. Also for the list, they are immutable. So you're not changing any list, you're just using the list for the creation of a new list. And well, you can check the last part that we did to work on your own task, which is going to be for the price list of 3 auto shops, give an overview of the number of prices in total, the highest price, and the 2 lowest prices. So you're gonna work with 3 separate lists. So you have shop 1, 2, and 3. These are the prices of the different shops. Then you're gonna create a function that does the work for you. Okay, just to make sure that you're not gonna do it by hand. Just to say it, try out 2 different strategies. One where you're gonna use the 3 function inputs, and one where you're just gonna use 1 function input. What do I mean by that? In this last function, the compare grades, we have 2 function inputs, the older grades and the newer grades. And then over here, we combined it together. Now, in this function, we needed to get the 2 of them separately because we wanted some information on the separate lists as well. But if we would have not been interested, for example, in this line, then there are 2 options. We can either ask for the older grades and the newer grades as 2 separate lists, and then we combine them together, or you can actually do that first. So just for you to get a little bit familiar with creating functions and asking for input and things like that. So I will see you in the next video. We're gonna continue doing amazingly fun stuff on lists.